Hello mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video, I created an easy to follow summary on analytical geometry. We are going to be looking at all the important properties you need to know under the headings of the gradient of a line. We're going to be looking at the formula that you can use in calculating the gradient of a line. We're going to be looking at the equation of a line and the formulas that you can use in calculating the equation of a line. We're going to be looking at the distance formula and the formula that you can use in calculating the length of a line between 2 points. We're going to be looking at the midpoint of a line and the formula that you can use in calculating the midpoint between 2 points. And we're also going to be looking at the inclination of a line. Okay, we're going to be looking at how tan of theta is also equal to the gradient of a line. All in the efforts to help you better approach your test and exam questions on analytical geometry. My YouTube channel is all about simplifying mathematics problems so that you can enjoy doing mathematics and ultimately increase your maths grade. If you are a high school student and you find mathematics difficult to understand, then make sure you are subscribed to this channel because I am about to make learning mathematics super fun and easy. I will also be uploading a follow-up video where I summarize all that you need to know on circles in analytical geometry and the equation of a tangent to a circle. So guys, without further ado, let's get started with the video tutorial. So we're going to start off by looking at the gradient of a line. The gradient of a line is defined as a slope of a line, and it shows how steep a line is. Okay, the formula that we use for calculating the gradient of a line is given as, which is equal to y2 minus y1 all over x2 minus x1, or change in y over the change in your x, where in this case the x1 and the y1 and the x2 and the y2 are points on the line. Okay, another important thing that you need to know about gradients of a line is that a gradient of a line can either be less than 0, it can be equal to 0, it can be greater than 0, and your gradient can be undefined. So how would it look on a graph if your gradient is less than 0, right? So if you had a gradient that is less than 0, how would that look on your graph? So you've got a graph there, and if you had a gradient that is less than 0, it would look something like that. Okay, let's look at what would happen if your gradient is equal to 0. Your line would look like that. Okay, it would be a straight line that is parallel to your x-axis. And then what would happen if your gradient is greater than 0? It would look like that. And what would happen if your gradient is undefined? Your line would look like that. Okay, so these are the different cases or scenarios of gradients you can get of a line. Okay, there's also other important properties about gradients of lines that you should know. If you have two lines Okay, you are told that those lines are parallel to each other. Okay, what would that mean about the gradient? Okay, so let me just quickly put that down for you guys. Okay, and they tell you that you've got two lines and they are parallel to each other. What does this tell you about the gradients? Lines that are parallel mean that the gradients are equal, right? So if we were to call this, obviously these lines are parallel to each other, and this is line A, B, and this is line C, D, right? This means that, like we said, line AB is parallel to line CD, meaning that the gradient of AB is equal to the gradient of CD. Okay? What happens if you've got two lines and they are perpendicular to each other? What does that information tell you about the gradients? So I'm going to put that down. You've got obviously line there and another line there, right? So we can clearly see that these two lines are perpendicular to each other. What does this tell us about our gradients, right? If I were to label my lines as A, B, and then C, D, right? If my AB is perpendicular to line CD, that tells me that the gradient of line AB times the gradient of your line CD is equal to -1. Okay, so those are the two important properties that you really need to remember in analyzing your analytical geometry questions. That if you have two lines that are parallel, if they tell you that lines are parallel, that should tell you that that means that my gradients are equal. And if you have two lines or a line that is perpendicular to another line, right? If they tell you that line AB is perpendicular to line CD, then that should tell you that the product of these two lines should give you a -1. All right, let's look at the distance formula. So the distance formula is used to determine the length between 2 points. All right, so I'm just going to give you guys a quick example. You are given obviously like 2 points, right, on your Cartesian plane, right? Given 2 points on your Cartesian plane, and right, so let's say those are the 2 points that we are given, and we are told that point A, right, is equal to x1 and y1, and point B is equal to x2 and y2, right? To get the distance or the length of this line, we use the formula of AB is equal to the square root of, x2 minus x1 all squared plus y2 minus y1 all squared. Right, so this is the formula that we use if you are required to get the length of line AB or the distance from A to B. So let us actually look at a quick example. You are given the point L, which is in equal to -5 and -2, and the point M, which is equal to -1 and -6. Right? And you're required to find the length of the line from point L to M. Okay, so from what we have just learned about the distance formula, we know that to get the length of LM, right? Get the length of LM, we use the formula x2 minus x1 all squared plus y2 minus y1 all squared. Right, so that is the formula that we use to get the length of line LM. Right, another thing I also do is that I label my point. So it goes from point L, right? It goes from point L to point M. So I label my point L as the first point and my point M as my second point, right? From point L to point M, right? And then let's just substitute our values, okay? So what is our x2? Our x2 is equal to -1 minus, what is our x1? -5, right? And that is all squared plus, what is our y2? It's -6 minus, what is our y1? -2 all squared. Okay, you're just gonna quickly punch that into our calculator and see what we get. I think I'm just gonna simplify this further for someone out there. All right, so it's gonna be -1 minus and minus is plus 5 all squared plus -6 minus and minus is plus 2 all squared. All right, and then I think it is pretty clear from here what we're working with, guys. You can just simply punch it into the calculator because we're not trying to complicate our lives, and you get 4 square root 2, right? So the distance of, or the length of line LM is equal to 4 square root 2. Okay, so now what happens if you are given the length of a line and one coordinate and you need to find the x or the y value of the other coordinate? Have a look at this example. We are given the length of the line or the distance of the line, and we are told that PQ is equal to 2 square root 5, right? And they tell us that the coordinates of P is 5 and 2, and Q is 3 and T. We need to find the value of T, right? So this is where we use what we know about the distance formula and work backwards to find the coordinates that we are looking for. Okay, so let us get started. We know what the distance formula is, right? Okay, let's just start off by doing that, right? We given P, Q, right? And then we told that the distance or the length of this line is equal to 2 square root 5. We are given the coordinates of P, which is 5 and 2, and we are given the coordinates of Q, which is 3 and T. We are asked to find the value of T, right? We know that we can use the distance formula of PQ, which is equal to x2 minus x1 all squared plus y2 minus y1 all squared, right? Okay, and then we simply substitute what we are given and see if we can work with that. We know that the length of PQ is 2 square root 5, so we put that there, right? And then I always like labeling my points. I name this my point 1, I name this my point 2, right? And then what is our x2? Our x2 is 3 minus, what is our x1? Right? Our x1 is 5 all squared plus, what is our y2? It's the t, right? Minus, what is our y1? It's the 2 all squared. Okay, what do we do now? We square both sides, right, to get rid of that square root on that side. So you're gonna have, right, so if you square both sides, you are going to be left with 2 square root 5 all squared is equal to 20. Right? And that is going to be equal to, what's 3 minus 5 all squared? 3 minus 5 all squared is equal to 4 plus t minus 2 all squared. Right? I'm simply going to move this 20 to the right hand side. So it's going to be 4 minus 20, going to give us minus 16. And I'm simply going to multiply this out, right? So I'm going to have, you basically square the first term, multiply these two terms together, which is minus 2, and you double it, which is minus 4t, plus you square the last term, and it's going to be plus 4, right? You continue to add your like terms, which is going to be t squared minus 4t, and then minus 16 plus 4 gives us minus 12, right? And then we continue to basically factorize this just using the process of inspection. You want a negative, therefore you have to have a negative and a positive sign. Factors of 12, that will give you a 4. It's 6 and 2, and therefore the proper combination that will give us a negative 4 is a minus 6 and a positive 2, right? Meaning that, oh, why am I saying t? No. Alright, so this is basically x and not t. And this is supposed to be t and not x, not a train smash. So you're going to put the t there, right? Okay, and then therefore we can conclude that our t is equal to 6, or our t is equal to negative 2, right? So this is our values of our t. Alright, let's have a look at the equation of a line. Alright, the equation of a line. How do we calculate the equation of a line? Right, you can use these 3 ways to calculate the equation of a line. Firstly, alright, you'll probably be given a gradient and the y-intercept, right? And then you can use the formula of y, which is equal to mx plus c, to get the equation of a line, right? And this, you use it when you're given a gradient plus a y-intercept. Okay, right? If you are given a gradient and the coordinates of at least 1 point, then you can use the formula y minus y1, which is equal to mx minus x1. Right, so this formula here, you use it if you're given the gradient plus at least 1 point. Right, at least 1 point on the line. Okay, and lastly, you can use both m, which is equal to y2 minus y1 over x2 minus x1, and y, which is equal to mx plus c, if you are given 2 points on a line. Right, so how can you use this, right? If you are given 2 points on a line, the first thing you can do is obviously calculate the gradient of the line using the 2 points, and then you can obviously substitute the gradient that you've calculated into this formula and another point into this formula. Alright, I'm just going to quickly go over this again. If you want to calculate the equation of a line, you can use these three methods. The first method is, if you're given a gradient plus a y-intercept, you can just simply use the formula of y, which is equal to mx plus c, where you simply directly substitute your gradient and your y-intercept, and you can get your equation of a line. Number two, if you're given a gradient plus 1 point on the line, right, then you can use the formula of y minus y1, which is equal to mx minus x1. Right, and if you are given 2 points on a line, you can start off by calculating the gradient, then you can go on and substitute the gradient that you obtained and 1 point to get the equation of a line. Let us put all of this into a practical example. Now, this first example says that if the gradient is -2 and the line cuts the y-axis at 1, determine the equation of the line. Right. Remember what we said. We said that if you are given a gradient plus the y-intercept, you can just simply use the y, which is equal to mx plus c, and plug your values or substitute your values into this equation to get the equation of a line. Okay, so let's just do that, right? So they're telling me that the gradient is -2, so that's our m, right? So our m is -2, and our c, because it cuts the y-axis at 1, is 1. Therefore, we use the formula y, which is equal to mx plus c, and we simply substitute the values that were given to us, which is the m, -2x, plus the c, which is 1, and this is our equation of the line. Let's look at the next example. If the gradient of a line is -2, right, and the point, you're given a point which is -1 and -4 and -1 lies on the line, find the equation of the line, right? What did we say here? We said that if you are given a gradient and at least 1 point, then you can use the equation of y minus y1, which is equal to mx minus x1. Okay, so let's do that. We know that we're supposed to use the equation y minus y1, which is equal to mx minus x1. Right? We're given 1 point, which is going to be our y1 and our x1, right? Which is y minus, what is our y1? -1, which is equal to, what is our m? Our m is equal to -2, x minus, what is our x1? Which is -4. Okay, so it's y plus 1 is equal to -2, x plus 4, and then if you simplify this further, y is equal to -2x, right? -2x minus 8 minus 1, right? And then what do you get? You get the equation of our line to be -2x. So this is -8 minus 1, which is minus 9. So now let's have a look at the midpoint of a line, right? The midpoint of a line is defined as the point that is halfway between two endpoints of a line. What does this mean, right? 2 points that are on a Cartesian plane, right? And you want to determine the midpoint of these 2 points, right? So let's say you've got point A, right? You've got point A here, and you've got point B here, right? So the midpoint is the point that is halfway between these 2 points. So it is that point there, right? Okay, so if I have my point A here and I've got my point B there, right? This is going to be my midpoint. Okay, if A has the coordinates x1 and y1 and B has the coordinates x2 and y2, to calculate the midpoint between these 2 points, we use the formula of your midpoint is equal to x1 plus x2 divided by 2, right? And the y2 plus, the y1 plus y2 divided by 2. That is how we get the midpoint between 2 points. So now let's look at a quick example, right, and see how we can apply this knowledge. So the question says, for a line passing through 2 points, which is point A, which is 6 and 6, and point B, which is 3 and negative 2, and 2, find the coordinates of the midpoint of AB. Right, we know that the midpoint is the point that is halfway between the 2 endpoints, right? We're given A and we're given B, right? And we just want to find the midpoint between these 2 points. Okay, to find the midpoint of AB, we use the formula of AB is equal to, remember we said it's x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Right, I like labeling my points. I say this is my point 1 and B is my point 2, and then I say that x1 is the 6 plus x2 is the 3 divided by 2. Y1 is the 6 plus y2 is the 2 divided by 2. So it's 6 plus 3 divided by 2. 6 plus 3 is 9 over 2. And then 6 plus 2 is 8 over 2. And to just simplify this further, we'll be left with 9 over 2 and 4. Therefore, the midpoint has the coordinates of 9 over 2 and 4. So now what happens when you are given the midpoint and one of the endpoints on a line, right? And you're required to calculate the other point, right? Let's look at an example. You are given the midpoint of a line AB as 1 and negative 4. You need to find the coordinates of A if the coordinates of B are 4 and negative 3. Okay, so basically that's what we have. We are given this midpoint and we are told that it's 1 and negative 4. We are given the coordinates of B as 4 and negative 3, and we basically have to calculate the coordinates of A, right? We're looking for the coordinates of A, right? What do we know? We know that the midpoint of line AB is given as x1 plus x2 all over 2 and y1 plus y2 all over 2, right? Okay, and then we know that we are looking for obviously the x coordinates of A and the y coordinates of A, right? So what we're going to do is we're going to separate this, right? And we're going to say that we already know what the x value of our midpoint is. So it's 1 is equal to x1, which is the value that we're looking for, plus x2, which is, remember that you must always label my points, right? So our 1 is the x1, plus our x2 is 4 all over 2, right? And then for the y, we already know that it's negative 4. So we're going to say negative 4 is equal to our y1, and obviously the y1 we're looking for, plus our y2, which is negative, it's negative 3. It's going to be negative 3 all over 2. I'm going to simplify this. We're going to have 2 because we multiply the 2, and we're going to be left with x1 plus 4, and then 2 minus 4 is going to be equal to our x1, right? So 2 minus 4 is equal to minus 2, right? So that's the value for our x1, and then let's find the y1 value. Negative 4 times it by 2, so negative 4 times it by 2 is going to be negative 8, which is equal to y1 minus 3. Okay, minus 8 plus 3, because you move it to the other side. Minus 8 plus 3 is minus 5, right? And that is our y1. Therefore, we can conclude that the coordinates of A is negative 2 and negative 5. And lastly, we are going to be looking at the inclination of a line, right? So what is the inclination of a line? The inclination of a line is the angle that a line makes with the x-axis, right? What do they mean by this, right? If you have your Cartesian plane, right, and there is an angle that is formed, obviously that's your line, right? And as you can see here, we have an angle that is formed with our x-axis. Okay, so that is the inclination of a line, right? Okay, so if you were to label this diagram as your A, your B, and this were to be a dotted line that goes all the way down. If you had to find the tan of this angle, right? If you had to find the tan of that angle, what would you do? What do we know, right? We know that the tan of theta is equal to your opposite side over your adjacent side, right? Okay, we're going to call this point here your point C, right? And our opposite side is our BC, and our adjacent side is our AC. Okay, and that, if you guys can see, is also the same as saying your change in Y over your change in X. Okay, therefore, it is safe to say that a gradient, right, the gradient of our line AB is equal to the tan, or the angle of inclination. right? 10 of theta. Alright, let's just look at a few examples. So in this example, we are told that line AB, right, is perpendicular to CD, right, which has a gradient of -4. We need to find the inclination of AB. Okay, so what do we know from what I have just told you here, right? We know that inclination, right, is equal to the gradient. Okay, so that's going to be our starting point. Okay, we know that the inclination is equal to the gradient. Right, that's the first thing you know. What are we given? We are given that line AB is perpendicular to line CD. Right, we are told that AB is perpendicular to CD. Right, AB is perpendicular to CD. What does this mean? It means that, right, this means that the gradient of AB multiplied with the gradient of CD should give us -1, right? This is an important property that I mentioned to you guys when I was explaining perpendicular. When you have two lines that are perpendicular and two lines that are parallel, what does that mean about the gradient, right? Meaning that, okay, we're looking for AB, right? We're gonna put that as our x, multiply by. We already know that the gradient of your line CD is equal to -4. We're going to put that there. And that should give us -1, right? Okay. And then when you just simply solve this equation for x, right, you find that the gradient of m of AB, right? So you can simply just put the x there, or you can just simply leave it as your gradient of AB, right? Gradient of AB, right? So solving for your gradient of AB gives us -1 divided by -4, which is equal to 1/4. Right? So the gradient of AB is 1/4, and therefore, right, we know that the gradient of AB is also equal to the tan of theta, right? And then we can substitute the 1/4, which is equal to your tan of theta, right? And then you just press your shift tan of 1/4, and you get your angle of inclination to be 14.04 degrees. Okay, let's look at a second example. Right, so in this example, we need to determine the inclination of a straight line that passes through the points P and Q. Alright, what do we know about our angle of inclination, right? We know that your gradient of our line PQ is equal to tan of theta. Alright, so what does this tell us? We can simply calculate the gradient of this line, right? And that will help us to determine the angle of inclination, right? Because we already know that it's equal to our gradient. Okay, so let's get cracking. Okay, how do we calculate our gradient again? We use the formula of m, which is equal to y2 minus y1 over x2 minus x1, right? And then I like labeling my points. That's my 1 and that's my 2. What is our y2? It's 10 minus, what is our y1? It's 2 over What is our x2? 3 minus, what is our x1? It's minus 6. Okay, just checking. Y2 is 10 minus y1 is 2 all over x2, which is 3 minus x1, which is minus 6. Let's punch that into our calculator and see what we get. So it's 10 minus 2 all over 3 minus 6, and we get that our gradient is 8 over 9. Okay, therefore, okay, we know that your MPQ, the gradient of a line PQ, right, is equal to 10 of theta, right? And then you simply substitute that 8 over 9, which is equal to 10 of theta, right? Then you press your shift button and you turn and you put the 8 over 9 and you get that our angle or the inclination is equal to 41.63 degrees. Okay guys, so let's do a recap of this lesson. We started off by calculating the gradient of a line. If you're given 2 points in a line, then you can simply calculate the gradient of that line by using the equation m is equal to y2 minus y1 all over x2 minus x1, right? We went on to look at the equation of a line, and I mentioned that there's actually 3 ways that you can get the equation of a line. The first way is if you're given your gradient and 1 point or your y-intercept, then you can simply substitute that into your y, which is equal to mx plus c, to get the equation of a line. Secondly, you can also get the equation of a line if you are given the gradient and at least 1 point. Alright, therefore you can just substitute that 1 point and the gradient to get the equation of a line. And lastly, if you are given 2 points, right, you can first start off by calculating the gradient of a line and then substitute that gradient into the equation and the other point to get the equation of a line. We looked at the distance formula and how we can basically apply it to calculate the distance between A and B, or the length of a line. And we said that the distance formula is given by the square root of x2 minus x1 all squared plus y2 minus y1. We also saw that they can sometimes ask you questions in a different way, whereas you're given the distance and you're actually required to find the coordinate, right? And the most simple way to do that is to just substitute all the values that you're given and you just solve the equation. We looked at the midpoint rule, right? And we said that the midpoint of a line, right, is the point that is at the halfway mark between 2 endpoints, right? And we looked at the formula that you can use in calculating the midpoint of 2 endpoints of a line, and we find that that is x1 plus x2 over 2 and y1 plus y2 over 2. Alright, and we also looked at the inclination of a line, and we said that the inclination of a line, or tan of theta, is equal to, we know that it's opposite over your adjacent, right? And that is also the same as saying your change in y over your change in x, right? Which is the same as saying the gradient of your line AB is equal to your tan of theta, right? And we looked at, right? And we looked at examples that you might be given, where obviously they give you things. They tell you that the point of your line AB is perpendicular to line CD, right? And you need to find inclination, right? And then there's certain things that we knew about lines that are perpendicular to each other. We know that the product of two lines that are perpendicular to each other should give us -1. And we found that obviously then that would mean that the gradient of our line AB is supposed to be 1 over 4. And once we found the gradient, then we can use the general formula of the gradient is equal to tan of theta to find the angle of inclination. Alright, so today's video tutorial was just a summary or an overview of what you guys need to know when it comes to your gradient of a line, the equation of a line, the distance formula, the inclination of a line, and the midpoint of a line. Alright guys, so please also make sure that you do subscribe to the channel, because the following videos that I will be uploading will be on circles in analytical geometry and the equation of a tangent to a circle. Right? I will also be doing past papers where I actually go in depth on these topics on analytical geometry. So please make sure that you are subscribed to the channel, and I will see you guys on my next upload.